So my name is Daan Beelen. I'm with the Sand Consortium at the Colorado School of Mines. My presentation is titled Shallow or Deep, and it's about quite a dramatic reinterpretation of some fairly prominent outcrops that formed in the Miocene Rifian Corridor. So this is what the Western Mediterranean area looked like during the late Miocene. So you can see that the Strait of Gibraltar didn't exist at this time. And instead, the exchange of water between the Atlantic Ocean and the Mediterranean Sea was facilitated by these two corridors. So there's the Beete Corridor in what's now southern Spain, and the Rifian Corridor in what is now northern Morocco. Now, personally, I think the term corridor is actually kind of a bad name because, as you can see, the current interpretation is that these are a system of partially connected straits, seaways, inlets, bays, and islands. So I think what would be a better name would be the Rifian Archipelago. Now, what that means for the outcrops that we're talking about is that their specific position within the entire depositional system cannot really be inferred from like a larger context because the paleogeography is so erratic and poorly constrained. It's hard to tell if this particular outcrop was in the center of the corridor or somewhere on the fringes or wherever. So the outcrops that we're going to talk about are in this red circle at the bottom of the figure right there. So this is a 3 times vertically exaggerated satellite image of the outcrops in question. It's the succession that is exposed is 209 meters thick. It starts right there near the lake and it goes all the way to the top of this sandstone layer. The section is comprised of 3 roughly equally thick cycles, and the entire thing contains 3 facies. The facies 1 is at the bottom of the section. They're bluish, grayish clay stones. Then there are some. Then facies 2 is more grayish, planar laminated marlstone or siltstone, and facies 3 is kind of the more spectacular facies that is the main interval of interest, and it's basically cross-stratified sandstones or mixed carbonate silicic sandstones. Right, so these facies 2, which is the roughly homogeneous, sometimes planar laminated siltstones, sometimes contain these sandstone beds that we interpret as turbidites. Okay, so the current interpretation is that these are unique, kind of almost never before seen examples of contourites in outcrop, which are deep marine, bottom current, geostrophic bottom current controlled deposits. So on the left bottom side, you see the first interpretation, which was made in 2017. And the sandstones that are in the Allou outcrops are herein interpreted as these bottom current controlled sheets that formed at the bottom of the corridor. On the right side, you see a more recent diagram, which kind of shows the same thing, where you see these sandstones that formed in the bottom of this corridor, quite in the center, in deep marine conditions. So the reason that this is such a big deal is that contourites are a bit of a topic of current research interest. And these rocks supposedly are the unique examples of these contourites in outcrop. Now, contourites that form really deep at the bottom of the ocean, basically, they have a very low preservation potential. So for that reason, they are quite rare in outcrop. So supposedly these are very important, and all sorts of interpretations have been based on this idea that these are unique deep marine bottom current deposits. So what do these sandstones actually look like? Well, in terms of macrofossils, they mostly contain barnacles and other types of bivalves, clams sometimes. Another common macrofossils that you find are scallops. So in this case, you can tell that it has both the valves still attached. So that's an indication that this is not a resedimented fossil, but it perished in situ. And obviously barnacles, clams, and scallops are not typically associated with deep marine environments. They're more commonly found in shallow marine types of areas. In terms of ichnofossils, it's kind of the same thing. Most trace fossils are thalassinoides, Scolitia, or Macroonychus ichnogenera, which are different types of horizontal burrow networks, usually made by shrimp and things that live in kind of shallow marine environments. And this is actually corroborated by some of the workers that are pushing the deep marine contourite interpretation, who say in their paper that the ichnofossils at Allou actually look a lot like shallow marine ichnofossils, right? So we have shallow marine macrofossils, shallow marine ichnofossils. In terms of sedimentary structures, it's also not much different. Most sedimentary structures that you find are associated with tides. So for example, rhythmic bedding is prevalent, which is associated with tides because tidal environments tend to have these rapidly fluctuating current intensities. Another thing that you find quite commonly are mud drapes and muddy layers, and flazer bedding, which is rapid alternation of muddy and sandstone lithologies. Kind of the larger sedimentary architectures are essentially stacks of cross-stratified intervals, or basically stacks of fossil dunes, which again is quite typically associated with kind of pro-delta or delta front, not very deep sedimentary environments. Here's another example of some stacked dunes. In the top of this particular section, you can actually see some evidence for wave reworking as well, which is quite rare in these areas. But here there's some hummocks and swales, so there might be some indication that there's wave action in this environment as well. So just to compare this type of architecture with known tidal environments, here's an example of stacked mixed carbonate siliciclastic dunes that are exposed in Corsica. And here are some more tidal siliciclastic dunes, stacked dunes that look really similar to the ones in Ben Allou that are found in a tidal environment in the Sirte Basin in Libya. So then if everything looks kind of shallow marine, why do people think that this is deep marine? Well, the original paper that made the Contourite interpretation, they state that the estimated environment of deposition is shelf slope transition, which is roughly 150 to 250 meters water depth or slightly deeper. And the water depth of deposition has been inferred based on the benthic foraminiferal assemblages contained in the hemipelagic marls of the studied sections. Sampling for biostratigraphy was carried out in the finer grained marls and muds interbedded with the sandstones. So essentially what they're saying is that they know it's deep marine because they've sampled the finer grained facies in between the sandstones. So I call those facies 1 and facies 2. And then they extrapolate the foraminiferal assemblages from those finer facies into the deeper facies without actually sampling the sandstone facies themselves. So during my fieldwork, I did actually sample the sandstones, and I made my own foraminiferal interpretations. And those clearly show that the sandstones have quite different foraminifera from the finer grained facies. The sandstones are actually dominated by ammonia and Alphidium genera, which are again typically associated with shallow marine, sometimes even brackish water environments. So of course, when I show this, nobody believed me. So I had to double check my foraminiferal interpretations. So 3 specialists actually double checked this thing. So the independent foraminiferal samples were collected directly from all facies. They were double checked in a blind test. So none of the experts had any information on my analysis or any other existing analysis, and were giving washed but unpicked raw samples that each contain thousands of individual microfossils. These experts are highly experienced with a combined century of experience with describing and interpreting foraminifera, and they concluded that the assemblages in the Ben Allou sandstones were deposited in situ due to their intact nature, and were not part of a resedimented assemblage. And they stated that the sandstone foraminiferal assemblage formed in shallow interneritic water depth, which is estimated 0 to 30 meters, while the marley and clay facies were formed in deep middle to shallow outer neritic water depths, which is estimated 60 to 140 meters. So in summary, we basically agree with the original interpretation in terms of the finer facies, but clearly the coarser facies, the sandstones, have significantly shallower foraminiferal assemblages. So that leads us to our independent interpretation, which is that the succession formed under conditions of changing sea level, where you have a relative low stand in sea level during the deposition of the coarser sandstones, and then deposition of the finer grained facies in between during high stands in sea level. Now, based on biostratigraphic age markers, we know that the entire succession formed in roughly 300,000 years of time. So according to the 3 cycles, that would correspond to roughly 100,000 years per cycle. And this is exactly what the current literature tells us, that this region in Morocco, and basically during the Upper Teutonian, the entire glaciocenotic regime was controlled by 100,000 years sea level fluctuations that were at least 50 and probably closer to 80 or 90 or 70 meters. So that's plenty of amplitude to allow for our interpretation of shallow tide-dominated sandstones interbedded with much finer, deeper pro-delta facies. All right. So what you'd find at the bottoms of these sandstones are these laterally extensive surfaces of erosion, which in terms of sequence stratigraphy would be called a sequence boundary. So as the sea level falls, the shallower facies, they incise and erode into the deeper pro-delta facies. And then at the bottoms of the sandstones, there is the transgression, so the flooding during the high stand, and eventually the formation of more of the finer facies. So we understand that this reinterpretation is quite dramatic in terms of the implications for many existing studies. But the reason that we decided to push for it is basically twofold. First is that we saw some problems with this existing paleo water depth reconstruction, which is basically an undersampling of the foraminiferal assemblages that omitted the sandstones. And then second, we believe that based on the macrofossils, the ichnofossils, and the sedimentary structures, basically a better interpretation that fits better with the data would be shallow marine tide-dominated deltas formed during a low stand, interbedded with relative high stand, pro-delta, and perhaps shelf facies. So that's it. Does anyone have questions?
Thank you so much. Yeah, if there are questions, please feel free to put them in the chat or to raise your hand. You can get them answered. All right, last call for questions.
Hey, Dan.
Hello.
Can you hear me? It's Peng Fei.
Hi.
So I know it's good work, and just curious. So you've listed all the evidence of shallow water origin. Did you notice any evidence for deeper water origin or deeper water interpretation?
In the sandstones?
Yeah, in all of your outcrop, actually.
Well, so the mudstones, which we interpret as the deepest high stand facies, they have some organic matter in them, so like 1% or something. So that would indicate dysoxic environment. So those would probably be, I mean, fair, like tens of meters water depth, but probably not more than 100. Other than that, in sandstones, I've seen absolutely no indication that these are anything other than almost kind of the classic tide-dominated shallow marine environment.
Mm-hmm. Okay, so those 3 cycles that you mentioned, is there any, let's say, time equivalent outcrops around that region that has like any chronology control or more precise like dating data?
Yeah, that's a very good question. There are multiple outcrops, and there are multiple outcrops in that area that are contemporaneous or roughly contemporaneous, based on biostratigraphic age markers that have also been interpreted as Contourites. But basically, the ones we visited, we saw the same picture. So there's another outcrop called Adergha, which is, at the top of my head, 30 kilometers to the east. And based on biostratigraphy, it's determined to be roughly contemporaneous. And that has the same succession of facies and also the same succession of corresponding micro and macro fossil assemblages. So the area is very complex, not just in terms of its paleogeography, but also in terms of its structural history. So there's basins, there's dissections of these basins into sub-basins, there's rotation. So clear spatial linking of these outcrops is many times really difficult. But based on biostratigraphy, there are multiple areas that have roughly similar successions of facies and are shown by biostratigraphy to be contemporaneous.
Okay, so biostrat is the main correlation method. There's no like ash tuff and stuff. Like,
Not really, no. It's
okay.
biostrat, yeah.
Okay. That's it. Thanks.
Okay, we've got 2 more questions for you. One from Gordon: was there significant current flow through the channels?
That's a good question. So another argument, so being faced with the idea that the foraminifera are undersampled, you could look for other arguments as to whether this should be a contourite, right? So one of those would be, yes, we know the Strait of Gibraltar has contourites, so has bottom current flow. So the Rifian Corridor must have had bottom current flow too. Sure, it might have had, I don't know. If it was the case, I don't think that's any indication that these particular outcrops are showing the record of that. So the Rifian Corridor, for all I know, probably had some outflow water in the same way that the Strait of Gibraltar has now. But that by itself is no evidence that these outcrops represent a record of that outflow water.
Great, thank you. We've got one more question for you from Kathleen. Have you compared your work to that done on the Pliocene barnacle-rich sandy facies in North Island, New Zealand, near Napier, also a corridor facies?
No, I haven't seen that actually. I think that would be very interesting to see because barnacles are the dominant macrofossil. So yeah, it would be very interesting to compare that.